course. Welcome to today's Micro-credential Topical Course. This course is funded by the Environment and Conservation Fund and organized by the Hong Kong Green Building Council. We would like to express our sincere gratitude to the Environment and Conservation Fund for their generous support. Today's topic is application of small unmanned aircraft on digital inspection of green building. We are honored to have engineer Dr. Lee from the Vocational Training Council as our speaker today. Now, let us welcome Dr. Lee to begin his presentation.
Good afternoon, everybody, honorable guests. It's my honor to present its topic in the Green Building Council today. Let me have a short brief about our content today. Today we'll have 5 chapters. The first one is introduction, and it is about the SUA related to the green buildings. And then we will, of course, need to talk about the low altitude economics. And then we'll have the statutory requirements for the operating of SUA. We will update you some legislations and also some guidelines are coming. And then we will have the third chapter about the SUA specifications and accessories in order to carry out the building inspections. And then chapter 4 is about the technology on photogrammetry and new technology of the LiDAR SLAM. It is my core talk of the technology. And then final chapter is the case studies on digital workflow and AI applications. I would like to tell that we are not concentrate on some tailor-made software. We are hopefully to bring some major software so that majority of us can use it in order to carry out the digital workflow. Let me start the introduction first. SUA related to green buildings. SUA can provide us rapid aerial data from building construction to facility management and monitoring. It provides us highly accurate real-time spatial data and visual intelligence. About the green buildings, vertical green walls, green roofs, and rooftop PV panels can be employed with the use of the SUA. And we can also use for the pre- and post-typhoon inspections, building thermographic surveys on structural crack, spalling, and water seepage, external drainage, gas pipework inspection as well. So we can use those SUA technology on the green buildings inspection. But we have the LAE, low altitude economics. The Chief Executive announced in the 2024 policy address not long ago, only less than 2 years ago. He has established the working group on developing low altitude economy. The LAE regulatory sandbox, structured testing framework to safely trial SUA and drone technology under the real-world conditions. It bypasses rigid airspace restrictions in order to collect the data, the technical data, test infrastructure, and pave the way for long-term legal updates. We call it the LAE regulatory sandbox. The LAE is a major promoter of using SUA and developing its ecology in Hong Kong. There are 5 main testing scenarios: logistics and distribution, automated drone deliveries, emergency and rescue. But to us, today's topic, it is related to the inspection and maintenance, for example, structural checks. It can also do number 4, civilians, number 5, LA infrastructure. We will touch a little bit on the mapping today, required spatial networks, signal strengths, GNSS, and unmanned aircraft system traffic management UTM solutions. For the altitude, normally the LAE is about from the range of 120 to 1,000 meters. But in fact, we will not reach that high. For the industrial drones, it is normally ranging from 120 to 300 meters, with a payload of 5 to 150 kg. But for the customer drones, the flying range is about 30 meters to 120 meters, and the payload normally is less than 3 kg. The main concern is about the accident rates, especially the fatal accident per hour flight hours. It is 1 in 100,000. It's still a little bit high to us. So we are targeting, we hope we can, with the improve of our technology, with our competency and our experience or legal requirements established, then we may target to reduce the rate, the fatal rate, to 1 in a million. For the statutory requirements of SUA, we have the remote pilot license, privileges, and limitations. The Hong Kong CAD, 民航處, the Hong Kong CAD has its regulations and orders, namely the Air Navigation Hong Kong Order 1995. The new one, especially for SUA, is the Chapter 448G, the SUA order. It is with effective on the June 1st, June of 2022, and amended on 18 July 2025, last year. Why it will be amended? Because of the sandbox. To echo or to implement with the Chief Executive initiative. So the SUA operation, in fact, is a risk-based approach. SUA regulatory requirements is based on the weight and the operational risk level. And in the coming PowerPoints, I will talk about the new changes of the order. But here we highlight some majority changes. The registration for responsible person of SUA and remote pilots, SUA categorization, type Cat B and Cat C operations are introduced. Operating requirements, permission for advanced operations, restrict flying zone FR6 and the drone map, advanced rating for remote pilots, and the insurance requirements. Before last year, the July, we don't have the Cat C, but now we introduce additional Cat C. We have the Cat A1, which is lighter than 250 grams. The Cat 2A, lighter than 7 kg. And then Cat B. Cat B is in the range of 7 to 25 kg. And C is about 7. Oh, there's something typo. It should be 150. So we have a number of requirements on registration, labeling of the aircraft, the equipment, and advanced rating training. And whether should we need the CAD's prior permission and the insurance are listed in this table. We'll see if it is a CAT A1, the simplest one, then we don't need to do anything. Everything is voluntary. But if you fall into the A2 category, that is the weight of the drone, then you need to do some mandatory works. For example, registration, SUA labeling, and even though you need to take some advanced rating training. In case it is outside the normal operations. And for Cat B and C, all are mandatory. Otherwise, you are breaking the law. This one is a most updated table. The CAD has the advisory circular, AC. It is from 01 to 17. 01 to 17. It is updated in the last, in this January. In this January, we newly introduced 14 to 17 about the permission for Category C SUA operations. That's why we now have the Cat C operation by Meitun, for example. And then it also allows us to do some facade cleaning operation using SUA. And we have the docking station to support our long journey flights, including to provide power support or recharging. And then it also allows us to do the cross-border operation from mainland China to Hong Kong here. But today, I would like to talk about the 05 and 06. It is about the building survey inspection operations and the aerial survey, previously known as the photogrammetry. The registration of remote pilot as a remote for the age of 14. So any person who reached the age of 14 can be a remote pilot registered through the ESUA platform in CAD. But if he wants to conduct Cat C operations, he must reach the age of 18. The remote pilot certificate should be issued if you are doing the operation B and C, or if you are doing some advanced operation that is outside the normal operations. Even though it is A1 or A2, you still need to get this certificate. And also, if it is belong above A2 or B or C category flight, then the SUA also be registered. But you cannot register your SUA through your company. It must be a lateral person to register as a responsible person or owner. It means you need to reach the age of 18. Any change of the information, address, contact number of you, or even though the registered person, then you need to notify CAD within 14 days. So this table shows the equipment requirement. For example, we need to have the safety system, including the flight logs and geo awareness. for A2 CAT, we need to keep it for 6 months. For the operating requirements, CAT A1 can only do the normal operations. But if we are outside the normal operation, we need to have the CAD prior permission. So, of course, CAT B and CAT C, you need to have the prior approval or permissions. And you see, we also introduced the cross-boundary operation. I remember in the 2021, when I first met with the CAD with my colleagues, I brought a team of colleagues to meet the CAD officer about how to arrange the first ever training in Hong Kong. And finally, we arrived, or they grant us the VTC as the first institution to do the training. And I'm the assessor up to now, still helping the VTC for this advanced rating operation examinations and trainings. This table shows the insurance requirement. For A1, we don't need to have any insurance. But for the A2, if it is outside the operation normal operation, we need to buy 5 million. Okay? But if for the other category, B or C, then you will see it depends, up to 20 million. Everyone will concern about how we can fly our A1 or A2 category. How to define the A1 and A2. It depends on the ground level, whether the altitude, the AGL, altitude above ground level. If you fly within 100 feet and your speed is less than 20 km per hour. 20 km per hour is about 5.6 meters per second. And you are not too close to the buildings from the 10 meter or people or any vehicles, vessels, then it is fall under the A1. But make sure your SUA is less than 250. For the A2, then you can fly higher, up to 300 feet. The speed is 20 km per hour. If you are flying fast, then you cannot keep too close. It should be 30 meters. But why we will fly so fast? Because we are going to do photogrammetry or aerial survey. So the other, I skip it. So the last two PowerPoint about the statutory requirement are the AC05, building inspection. In this one, it has shown the A1 CAT A1 here. You can review the 10 meter requirement, the 100 feet. If it is A2, you can fly higher, and you will see here we count from the rooftop. We count from the rooftop. So it has a flexibility for we to do the high-rise building inspection. But before we cannot do that. But the most important is you must have a control to the public access. So this is AC02, 06. Similar, we need to have the control about our vehicle and vessels. Why I said our? Because it is doing this aerial survey. Aerial survey normally is our site. within our site. Even though we help the government or highways to do the aerial survey, we should have their permission in advance. It means all the vehicles inside should be under control by the highways and the SUA operators. So we cannot fly over those, okay? And then we still keep the 300 feet and the 20 km/h requirement. Oh, let's speed up a little bit. The other CAD requirements are given in the 448A for the scheduled and non-scheduled air services to and from Hong Kong. 448B, the investigation of accidents. If we have some accident happened, then we need to refer to this one during after our operations. And the 448C, the air navigation, Hong Kong order, endangering safety of any person or property. The final one is the 448E, air navigation flight prohibition order. For the detail of how to operate SUA, we need to refer to the General Safety Guidelines for flying SUA. Another recent development is concerned about CIC, technical reference. In last month, the May 26th, it has conducted the second consultation workshop. CIC wants to publish a technical reference for application of drones and AI for building facade inspection. Although it is not non-statutory, but it is authoritative. So it will provide us minimum standards and good practice for the application of drones and AI in external facade inspection. It wants to promote the safety and reliability activity on site. We need to have transparent, clear documentation, audit trails, and human validation, apart from the CAD requirement of the advanced operations. And actually, they have the MBIS, Mandatory Building Inspection Scheme. They want to incorporate this technical reference in order to facilitate the conduction of this MBIS survey. And it also should be aligned with the CAT SUA requirements and our Personal Data Privacy Ordinance. They divide the building into 6 categories, A to F, from low-rise to high-rise C. And then D is the super high-rise building more than 40 stories. E is the heritage, 唐樓 and 唐樓, okay, with different variable heights. And normally we'll use the AI to help us to do this heritage rehabilitation. And then the final Cat F is special structures, including bridges, stadium roof, offshore installation, and other long standard forms. They have the 3 conformance or higher tiers to govern those 6 CAT buildings. The first one is standard tier. It is the lowest to moderate consequence of risk level. It has the QMS maturity. QMS is the quality management system with the process approach and plan, do, check, act cycle. Comply with the ISO 9001. And the second enhanced tier, it is it includes the CAT-C, complex facade MBIS, will fall into that enhanced tier. And it is moderate to high risk level. And then we need to do some statutory submissions for doing the work. And the critical tier include the CAT-D, E, and F. So it will have high it is the highest consequence of risk level. And we don't want the SUA will fall down or anything related from the payload will hit or damage the heritage buildings. So a full QMS is needed, and also need to align with the ISO IEC 17020. It also includes some competent person to do the building inspection or the MBIS. So in fact, we have the remote pilot in command according to the requirement of the CAD. And we will have a visual observer and field in charge. On the other hand, the buildings department also require the professional inspector, registered inspector. And we also need to have the data protection officer and AI assessor. When we do the data acquisition parameters, we need to here is the standard tier example for us as a quick guide for the MBIS facade inspection. For example, we have this 20 to 40 story residential building or mixed-use buildings. We need to have our planning, our team composition established. We need to have the ground sampling and overlap starting points. So the ground sampling distance rate is defined by the building category and minimum detectable defect size. The overlap requirements to improve our quality of the photogrammetry and then later on the AI processing. And then we need to have the standoff and viewing angles, which actually in our photogrammetry we should have our minimum or various viewing angles in order to collect a high quality or sufficient number of photos. But the point is, in their workshop or in their discussion, it seems missing out the new scanning technology. For example, the SLAM. Later, I will send a number of slides to show or to discuss the SLAM technology. And finally, the CIC technical reference will include the intelligence and planning, B, acquisition and operations. This already exists in the CAD requirement. And then we will have the D, QA and QC. But here, this one, C is the new one, the AI processing workflow and human validation requirements. Let's go to the SUA accessories. Before we fly the SUA, we need to have some specifications and accessory equipped to operate our inspection for the green buildings. We need to know our application, our purpose. For example, the RGB condition survey for the structure, the infrared thermographic survey for leak detection, for concrete spalling, or etc. And then do we need the point cloud record? But if it is the digital building or green buildings, normally the client would like to have the point cloud record. Actually, it is a byproduct of your photogrammetry or building inspection. And then once we got the point cloud, maybe we can draw the beam model or put it into the GIS modeling. There are some light SUA aircraft. For example, the DJI Mini 5, now it is 5 Pro, the latest version 5 Pro. the Mavic 4 Pro, Air 3S, and the Flip. You can see the price are reasonable. Those can help us to do most of the, except the number 2 IR thermography. Normally, most of them can conduct those. Survey condition, making point cloud record. Here are some specifications. The most important, the first one we need to know is, actually all of those are high resolution. Okay, at least 4K. But the most important is the weight. This one is still below 250 gram. Okay, 249. The battery is quite long. Normally, that can last an hour. If you want to do some more video recording, then we may use the Inspire 3. Inspire 3. This is the new model. The old model is Inspire 2. It is equipped with the Samuel's camera. And also, it will have the, you can see this autopilot. And it has a high grade of the ISO. But for us, as an engineer, apart from the taking video, we may use a higher grade of DJI SUA for the aerial survey. For example, the latest one is the DJI Matrix 400. The total weight can carry is 15.5 kg with a payload of maximum 6 kg. It can fly for an hour, and the wind resistance is 12 meters per second. In fact, normally we will fly SUA with a capacity half in order to reduce or to counterweight the wind resistance. So this one, if I remember, it has the maximum speed of 25 meters per second. So it can use half of its capacity to resist the wind, and then the half it can still within our allowable. Our allowable is 10 meters per second for Cat A2. So this one still can, but due to the weight of this one, it is not A2. But I mean, we will check the wind, whether it is suitable for us to fly a drone. We are going to use up half of our drone capacity. And then there are the other models, for example, the Matrix 4E Enterprise, 4TD, T means, or 4T thermal, infrared thermal. And let's sum up here. If possible, actually, we need to choose the lightest aircraft, the SUA first, from A1. Okay, rather than, oh, let's fly Cat C, of course, no. So, if possible, we will follow this. We will try to use the Mavic Mini 5 Pro, whether it can help us to satisfy our requirements. And then we will look up to the Air 3S with the pixel, 50 MP, the weight more than 700, and then Mavic 3T thermal with RTK. RTK is the georeference. So all of our metadata will have another set of the georeference, geocoordinates. But the point is, this one, although it is a thermal camera equipped, its resolution is not quite high. You know, we have a problem of we cannot reach the building too close. At least we need to keep 10 meters away. So whether this can help or not, if can't, then we need to look for the other option. For example, the matrix 350 RTK or 400 RTK. And then we can equip with our latest H30T, the thermal cam with zoom. Its resolution is the highest one, you can see. Okay, more than 1280 times 1024. So, but of course, there is a cost for that equipment. And the beauty is it has a high optical zoom, 34 times. But for the thermal, it is only 32 digital. Okay, but it's better than nothing. So this is the top thermal cam available in Hong Kong at the moment. And then the other one is the Samuel's L3. L3, it is the laser. Equipped with laser and the RGB cam. So with those, we can carry out our building inspection or the photogrammetry. Now let's talk about the technology. I will talk about the photogrammetry first, and then later on to the LiDAR SLAM. When we fly the SUA, we need the GPS. GPS is in the USA, okay? It is widely used in the SUA navigation to resist wind currents in order to maintain its position in the air. Otherwise, it will blow away, okay? If we don't have enough GNSS signal or unstable, then we need to change it back to the attitude flight mode. But it is very risky because we cannot see where the SUA will be blown away. So we need to land it immediately in order not to make not to jeopardize any accidents. But due to this factor, we need to limit our flight because there are some signal receiving problem or weak signal interrupt by objects, by buildings, by the reflective facade. Okay, although the CIC is going to give us the guideline on the cleaning of the facade, but there is a problem when we cleaning the reflective curtain wall facade glassy because it is glassy. And also thick cloud will also weaken our signal receiving. Jam signals, low signal acquisition due to nearby aircraft or electronic equipment. Lateral interference by ionosphere, terrain, mountain. Okay, you know, the signal will be blocked by mountain, signal will be blocked by tall buildings, and also the solar activities. If we all remember, the drone show was cancelled. So when we fly the drone for the purpose of aerial survey or photogrammetry, we need to concern our quality of the pictures or quality of the set of images. We need to have a good camera sensor size. How to define what is good, what is bad? We will have a simple calculation later. And then it depends on the height and the scale of the images. And then the accuracy of the camera, we need to calibrate it. We also want to have a good quality of image for measurement. And the pictures we are going to take should be LiDAR. It means 90 degree vertically. And also should have oblique angles. So we also need to have some control point. But if the SUA is equipped with the RTK, real-time kinematics, then we don't need to have these control points. Of course, we can have them as a reference for comparison. And then we also need to check the lapping, the end lap, the side lap, the photo lapping. You can see it is the LiDAR, 90 degree or 0 degree. It depends on how you measure. Okay, but it is pure vertical. And then we need to have some angles. The maximum is 30 degrees or 70 degrees. Okay, so that we will have two sets of photos in order to have a good quality of the set, the vertical direction. And also we need to have the control point reference. What are our reference points? Okay. In Hong Kong, we follow the HK90 80 grid coordinates. It is the International Hayford as our georeference system. It is a little bit different to the WGS84, the GPS system. Okay, and the definition is a little bit different. There are some minor deviation. You will see if you want to correct them. Okay. So here is the ground sampling distance for us to assess whether our quality of photos are adequate or not. It depends on the scale, the scale size. The scale is the sensor pixel size over the ground pixel. So this is the sensor pixel size of the camera. This is the actual ground pixel of the photo we are taking. So based on the triangulation, the triangle relationship, we just can measure the F and the H. H is our flight height. F is the focal length of the camera. So once we have the focal length of the camera is here. It depends on your SUA type or the camera you employed. Okay, some built-in GSD calculator or online GSD calculator allows you to input your drone models. For example, here we input the DJI Mavic 2 Pro, and then you will automatically know the focal length, the camera specifications. And then what we need to do is to input our height, 90 meters, and then you will calculate the ground sampling distance per pixel, cm per pixel. Here we got the 2.29 cm per pixel. Normally, for our professional surveyor, to do this kind of photogrammetry, at least it should be less than 10 cm per pixel. So this is very nice, 2.29. With the, it is easy for us, not only cost us a few $1,000, and then we can buy a Mavic. Okay, and then we fly up to 90 meters, and then it is actually it's quite high in our operation. We don't need to fly that high. So if you fly 50, then it will be only 1 cm per pixel. It is much better, much smaller than the 10 cm per pixel. Okay, before we fly the drone, we need to check the Hong Kong air map. It is 1 in 100K scale. So it is the Hong Kong air map. And when we look into here, we'll see there is the Disneyland or Penny Bay. Disneyland is a prohibited area. We cannot fly drone or SUA because there is a noise and visual disturbance. Okay, unless we got the permission from CAD, or it also has the other restrict flying zone given to us, including the Victoria Harbour. Okay, so before we fly, we need to check this map and also the ESUA drone map and any news. For example, in Wan Chai is very near the, or Causeway Bay, very near the Victoria Harbour. When we fly those, maybe sometime, maybe in the normal days we can fly, but if there are some events, okay, then you will be prohibited. Okay, then we cannot fly. So we need to check both, not only this air map, but also our apps in the ESUA. Okay, this is the autopilot. A lot of software, not only the built-in DJI can help, we can use the other, for example, Pixel 4D, we can use, and then it will help to control our drone. It has a lot of data given there. For example, the area we are choosing to fly, the distance, the height, the maximum speed we can control, the duration you will calculate out with, for example, here 40 minutes, 22 seconds, okay? And then we know a lot of information here. We can set our mission into this flight operation, okay? And then finally, we can also measure some distance we want. You see, here is our control. We fool the blue line to send out our electronic signal to the drone. Okay, the drone is flying from here to there. Okay, if we cannot reach, we'll use the other remote pilot to assist us to send another set. It means we have two control panels, namely the A and the B. And then we will pass our right to the B to do the last part of the flight. Okay. Now here is the Pixel 4D, very similar, and it also gives us a different mission. For example, here is the grid mission. This is double grid because we need to fly in different direction with different angle. As what I said, we need to have the opposite 70-degree angle to take photos. So we are not only to do one direction, but on the other hand, we need to do the other direction. Or we can do a circular mission around the building to do our building inspections or photogrammetry. Today, I need to talk about photogrammetry because I want to apply the photogrammetry technology to our building inspection rather than to just scan the front and then we scan the other side. Okay, the most important, or why we don't do it, for example, this circular mission in order to do the photogrammetry. Of course, we don't need to do a circular. If you want, you can split it into four times. Okay, four surfaces. Okay, we can do it in the east side, south side, west side, and the north side. Okay, and then it's the same. You will form the whole picture of the model, the building model. So I believe the photogrammetry can help us. So that's why today we talk about photogrammetry. And the later part is the SLAM. Later on, I'll talk about the SLAM. Okay, these are the images we capture through the SUA when we fly. So now we are going to do the software processing of the photogrammetry. After we took the photos, we'll put into the software to do the processing. We have the we need to start a new project. We import our images with the grid, Hong Kong 1980 grid, and then we tell the system our camera. We input our ground control point if we only have the photo information. The photo information, in fact, it has its metadata. It has its metadata about the leg long, the position, but it is not quite accurate, you know. And then we need to give them some ground control point so that the software can adjust to make the flat surface be flat, okay? The curved surface be curved, okay? So, and then you will do is aerial triangulation, and then you will do the other matching, and then you repeat to do the optimization. Finally, we will have the 3D models. When we have the 3D models, this software, Sky Photo, for example, normally we will use my company will use two software. One is the iTwin Capture Modeler. The other is the South Sky Photo, or even the Pix4D can help. And then we will have the true digital orthophoto model as the first output. And we will have a number of formats. For example, if it is point clouds, we will have the last XYZ and PLY. PLY, I'm going to talk about this one in depth in later SLAM technology, because PLY can help a lot. Otherwise, if we only use the last, you will find your computer or your graphic card cannot help too much. Okay, you will stuck or suddenly stop due to the memory or due to the size of the model. And then for the 3D mesh, we will have the object, PBX format, DXF, or we can put into the S3. We will have the scene layer package format. So for the orthophoto, we will have TIFF, GeoTIFF, digital surface model, DSM, or terrain model. The formats are those. Okay, here are some file formats for us to do the advanced analysis. After we have this 3D models, you'll see after we do the project, we'll have the ground control point report, we'll have the OSG, and then we will have high quality DSM, contour line. So here is the photos. We have 16 number of control point. Okay, at least we need to should have 4 corners. You can see the red dot, those 4, and then we need to make sure they are evenly spread at the corners. And then we can do our manual adjustment to speed up the AT aerial triangulation manually. Of course, we don't need to do if we don't want. But it will maybe we want to save some time for the computer. Then we need to do it manually. And then finally, we after it finish processing, we can do the measurement for the distance, area, by the TDOM, or we will have the 3D mesh. Okay, 3D mesh model. And then 3D mesh model is really important. Now, we move on to the building inspection. We, as I said, we are going to adopt the photogrammetry technology on the building inspection in order to make a 3D mesh model of the building. Okay? Here, not only for the building, we also want to put into the GIS software or environment. For example, here, after we use the Pixel 4D to fly or to do the processing, we'll put it into ArcGIS Pro. And then we will later on have our different analysis for the 3D model. We have mentioned about the dock. The DJI Dock 2 is the latest one. It can help to do the automated drone in a box solution for remote operation. For example, here, maybe we don't have enough power for the small SUA. So we need to have a dock to help. And this one is with the ingress protection IP55 rating. So it means it can resist dust and water. But of course, when it is raining, we cannot fly. We shouldn't fly, okay? Of course, it said it is suitable for various weather conditions, but we shouldn't fly, okay? But, and then we decide to house the automatically charge, okay? It is DJI Matrix 3D or 3TD with the thermal function. The system includes a built-in backup battery for more than 5 hours operation. Okay, it will open itself and then allow it to land automatically and then charge. Once it finishes, it will fly again to continue our building inspection for 3 buildings. Okay, before we move on to, or before we stop for a while for the break, let's talk about a few slides about the building inspection, the building condition survey. The building condition survey, years ago, I have helped the AIIB, Asian Institution of Intelligent Buildings, in writing their Intelligent Building Index manual on the chapter of the structural. The structural part is talking about how we conduct or how we assess the building inspection for crack, for water leakage, for spalling, using thermographic survey or condition survey. But now the latest version is version 5. It has 10 quality environmental modules. For example, the green index, space index, comfort index, working efficiency, culture, high-tech image, safety and structure. This is the chapter I helped them. Management practice and security, cost effectiveness, health and sanitation index. Altogether, there are 10, and the score is between 1 to 100. And then finally, we will arrive at some number of the score. That score will tell you your building is smart or intelligent enough or not, where you need to improve. Okay? So this is the roof IR thermography. You can see the blue is the water seepage through the roof to the underneath. And then you will see from the block or residential flat below, you will see the water is seeping down. And here, there are some spalling here, some water seepage here. Here, we can use the SUA to do the water test, for new buildings. The guys are using the traditional water test. They're using a hose to spray water. But in fact, we can do. But the point is, the problem is this one, the drone is not equipped with the high resolution of IR cam. So you cannot check too much. That's why I said we need to have equipped with the high resolution, maybe 1200 resolution to help. Okay? Hello? Let's go back to our core technology today about the SLAM. SLAM is the Simultaneous Localisation and Mapping. 同步定位與地圖建構. Okay, we call it SLAM. SLAM, in fact, the old version was the LiDAR SLAM only. The old version has LiDAR SLAM only. But now, the equipment normally will be equipped with a visual SLAM, RGB. You'll see this one has a camera over here. Okay, it is different to, although before we have our slide camera has also equipped with the RGB, but that RGB is different to here. It only gives the texture, But now here, this visual SLAM not only gives us the texture, but also give us the RGB georeference. So there are two core missions. This SLAM can help us to locate where I am, the positioning. For example, the Boston Dynamic, the dog, okay? The dog needs to know where it is, the AI dog, you know, where I am. So that kind of technology use the SLAM technology. The second one is to reconstruct the surroundings, reconstruct the mapping, okay? Not only to see, but also to have the surrounding mapping. So the SLAM algorithm application help us to navigate a fleet of mobile robots to arrange, for example, in warehouses, shelves, product, okay? Or to help the car to do the parking, self-driving parking in anti-sport, or to deliver a package of by navigating a drone show in an unknown environment. Okay, so this SLAM equipment can be handheld. You can see there's a stand here. We can handheld. We can put it into a backpack with a larger RTK antenna. We can put into the SUV vessel, small boat, 無人船. And then, of course, the SUA, or we call UAV, 無人機. And or we can put into the SUV or small car. But normally we will not put in the front. We will put at the back. Okay? At the back, not in the front. And as I mentioned, it is for robot dog as well, or our robot cleaner, robot cleaner or mop. This is the colorized point cloud display. In Hong Kong, you can see. We can fly the drone with that. We can install at the back of the SUV, you can see. Or we can put onto the vessel, small boat. And then we will have the both point cloud and textured with the color image. Okay, we can train and then we can repeat. We can ask the robot dog to repeat the mission. And you can see the guy handheld to do the survey. And then we will have those image and the point count, colorized image. The SLAM technology is achieved by 3D sensing. And it will have the reality construction by laser scanning, especially for the depth information. It has its own RTK and control points. So we will record the trajectory and the moving speed, direction, and our orientation in our mission. We have a track record to know what happened, okay? How we conduct the survey. Or moving trajectory will be obtained while mapping, similar to relative orientation of close-range photogrammetry, okay? Just like before we talk about the photogrammetry. For example, the J position will be counter-calculated by triangulation or triangle position of any 3 points. For example, A, B, C, we define or confirm our J position. While moving into information will collaborate with image point cloud to rematch and then map. Okay, the software will continuously to calculate, to redefine or to check the real position. The advantages is it will give us the direct georeference. It is independent to the ground control point. Okay, we'll go from J1, J2, J3 and with our triangulation calculations. And then it is suitable for different mobile platforms. And it is available from short to long scanning range. It is independent to GPS signal. Okay, once we know, for example, we know the point F, and then we can use it as a base or a reference we can continue to do. But better, we need to have a close look and then come back to the position F as a close look for the rechecking. Handheld is the most best performed surveying, handheld, okay? The poorest one is the SUA, of course, because the SUA is vibrating or moving in the air. So if we can, we do the handheld, but sometimes most of the time we cannot do because we need to do it building survey. So we have no choice but to use the SUA with the SLAM technology. And also it is very suitable for indoor if you use the handheld. And later on we will have case study to tell you. According to the RICS, Royal Institute of Chartered Surveyors, it said the point cloud should have LAX and E57. Okay, if a brand new SLAM equipment, you should have the format not only LAS but also the E57. And when we choose the suitable equipment, we also need to check whether it has the structured E57. Because as I said, the new equipment normally will be equipped not only the LiDAR but the RGB camera, which can help to embed images into files. And then after the post-processing, and then we will have the structured E57. So if your equipment can only produce the first one, then it is very old. The second one is not too good. Okay, the latest version should have those format. And E57 industrial standard from terrestrial scanners For example, Faro, LiDAR, Trimble, include color and intensity. So normally we use E57. And then I would like to spend some time on the PLY format. As I mentioned earlier, this one can help to save a lot of memory and the processing time. It is simple format from photogrammetry, easy to work with. Okay, so it is the best if we can have the E57 and the PLY format in our SLAM tool, scanning tool. Okay, and then they can help us to scan to beam and scan to CAD later on. SLAM output requirement, we need to have sharp color completeness, point position, errors we should know, and point cannot too sparse. And we need to have sufficient overlap. As what the RICS said, we need to have 60 to 80% overlap. So how is our SLAM equipment can it achieve this overlap requirement? So for the preferred specifications, we list out those for you as a reference. Okay? How many points per second, the operating range, the camera, the fisheye lenses. Normally, we will have 2 RGB camera. Okay? And the most important, as what I said, not only the LiDAR SLAM, but also RGB visual SLAM. Okay, and then the weight is a factor, only 1.7 kg normally. And here, different brand will have different software or cell phone application. Okay. This is very important if we can use our cell phone to control and also to analysis or to preview. So the apps is very important. And also, it also normally will have built-in point cloud processor and the 3DGS processor. This one is also very important, 3DG processor. It is called the Gaussian splatting. 3D Gaussian splatting. You can convert discrete 3D points to smooth, continuous visual representations by splatting them onto a 2D screen using the Gaussian kernels. The 3D episodes is the ball. It helps us to crop, to measure, and to record videos. We will have our viewpoint, different viewpoint. We can mark notes. We can also publish to the web viewer. Okay, and then we can export open format to the PLY. So let's talk about the group practice. If your SLAM equipment, I prefer it can have one-click full workflow. To do the reconstruction, to do the GNSS conversion, optimization, filtering, point cloud enhancement, shading, panoramic image and mesh model. Not step by step. Then it wastes your time and your preview is not possible. And then the post-processing editing allows us to crop, to reduce the noise, and normally we'll have the software with the AI help us to do the extraction or help us to do the beam modeling. For the data format, for example, this one, you will see it has the output of the .x beam. And the map, 2 files. What are they? The .x beam can help us to do the 3D GS. And the map is the last format, okay? The map, it is the file. we got. Okay, and then the original data is fully open, should be fully open. Archive contains GNSS files which are automatically aligned with the Hong Kong 1980 grid after software processing. So you will see those. We should have those files in our memory. Okay, so the other not good is only put here for reference. And then finally, as what I said, we need to comply with our RICS guideline. Yes, definitely. The 3D-GS actually use the LiDAR related technology to generate a realistic 3D model for real rendering. But this data processing is a GPU, okay? So we need a high-end computer or notebook so that we can produce the common format of PLY. It is more realistic than the point clouds. With small file size, it is only the PLY size is only 1/10 of the point cloud. 1/10. Okay, so not quite high-end computer can deal with this SLAM processing. It is suitable for assisting in drawing beam models and as a reference model in animation. But currently, it still has some limitation on the direct software support. But anyway, we can integrate into other software via the SDK. Okay, SDK. SDK is the software development kit. It is a bundled set of tools, libraries, and documentation that enables developers to build applications for a specific platform. Different software will have their applications and SDK applications. So the PLY actually is coming from the 3D-GS open format. As I said, the binary, okay, XB. And the 3D-GS open format is the SOG. And the splat, Gaussian splat is open format, compact binary. So with this technology, it can help us to process with AI. It can automatic removal of dynamic objects, for example, people or moving cars. It can help us to classify image into environment dynamic objects and static objects. It also can mask the environment, the dynamic objects. For example, the NRF, okay, neural radiance fields. It can learn a continuous 3D scene function using a neural network. Okay, it is very hit topic on the neural network. For example, the guy here, he can recognize and then trim, remove the guy because he is moving. And it has the multiple images with camera poses and are fed to the NRF. With this continuously optimized the scene model by rendering virtual images and comparing them with real images. It makes the geometry and appearance colors increasingly closer to realistic. Not only to cut, but also improve the color, the texture. But of course, it requires a lot of computation and need to be processed by, as I said, the GPU. We can use this technology to count people, to count or to calculate the area, the size. So this 3D-GS is a must in SLAM now. So this is a comparison between the point cloud and the 3D-GS. Okay, the most significant is the not only RGB but also color and capacity. And then it also records the orientation, rotation. But in the point cloud, we don't have that. Later, I'll show you the orientation and the track record of our survey scanning. And then, but of course, the disadvantage is the processing time is longer. It's longer, okay? But it still can be the data volume in 1 hour. You can see it has been reduced to 2G rather than 23G. We expect the AI can help us. And some software said they are going to give 3D breed models only with 1 key push. They said they can, but I don't know when. They said coming, okay? To make this nice Guangzhou city, the cloud model, point cloud model into B model, only need to press the button.
Thank you, Engineer Dr. Lee, for such an inspiring presentation. For the Zoom participant, please complete the post-course questionnaire by scanning the QR code on the screen or click the link in the Zoom chat to record your attendance before you leave. We would also like to extend our special thanks to the Environment and Conservation Fund for their continuous support. Thank you all for joining us today. As part of this project, we will be hosting various courses and events in the future. If you are interested, please follow our official website and social media channel for the latest update. If you have no further questions, you are welcome to leave now. Thank you.